Hi, in this video we are going to talk about sort in C++ STL. Sort is a general purpose library function for sorting any types of input. It is mainly used for sorting data stored in containers which allow random access. And example containers which allow random access are array, normal arrays, vectors, and DQ. These are some containers which allow random access. Random access means you can access ith item in constant time. So sort can be used to sort elements for all these containers. Here is an example of sort function. We have an array with these values 10, 20, 5, 7, and we call the sort function. So sort function in C++, it receives two addresses or two iterators. The first iterator or address is an address of the first element, right? So array name in C and C++, it gives you the address of first element. So your first address is address of 10. And the second address is the address after the last element, right? So this address is after the element 7. So if you talk about vector and DQ, it's going to be v.end, right? v.end because it gives you an iterator pointing to an element beyond the last element. So that is why for arrays, we do not pass array plus n minus 1 because that will give you address of last element. But we pass array plus n. That gives you the address of an element beyond the last element. This sort function is defined in algorithm library. We have two ways to call the sort function. One is just passing two iterators, and this way sorts your input array in increasing order by default. And there is another way where you can specify an order. So I've called two ways here sort by passing two parameters and by passing three parameters. So the third parameter specifies the order in which you want these items to be sorted. It's mainly a function. So your third parameter is mainly a comparison function that decides how elements are to be compared. Greater function in C++ is a general purpose comparison function which reverses the order. So the general order in increasing order, greater function gives you decreasing order. So we now know sorting. We know how do we call it using two ways. Let's guess the output of this program. So the first sort will change this array to 5, 7, 10, 20. Right? And then you print content of this array. So you will get output as, so output of this program is going to be 5, 7, 10 and 20. Now you call this sort again with greater function as a parameter. So what greater function will do? It will cause this sort to compare elements in such a way that greatest element comes first. So output of this part after calling this function is going to be 20, 10, 7, 5. So this part sorts your array in decreasing order, right? That's what you get here, and this is done because of the sort call, and this sort call changes your input array to increasing order, and that's why you get this output. Let us now talk about an example to sort a vector. We are given a vector and we want to sort it. So this vector initially contains 4 elements 5, 7, 20, 10. We call the sort function. In sort function we can call two ways. First way is passing two iterators, where the first iterator points to the first element and second iterator points to an element beyond the last element, right? So we pass v.begin and v.end here. In case of arrays, we pass the address of first element and address of an element after the last. So v.begin and v.end, and by default we get the elements in increasing order sorted. So this line prints the output as 5, 7, 10, 20. Here we have called the sort function again, but we have passed another parameter, third parameter, which specifies the order of sorting, and greater function is typically used to reverse the default order. Default order is increasing order and greater is going to change it to decreasing order. So the output after the sort called is 20, 10, 7 and 5. So when you pass the greater function as an argument, it reverses the order and you get the array in decreasing order. So this for loop prints this part and this for loop prints this part as an output. We have talked about simple sorting where we were sorting in increasing order and decreasing order. Let us now talk about an example program where we want to specify our own order. I've considered a structure which represents a point in 2D space where x and y coordinate values, and I have written my own comparison function here which is used to sort these points in increasing order of their x coordinates. Right, so this is my own comparison function and this is structure. We are going to sort an array of this structure. So we create an array of this structure and now we call the sort function using same parameters, array and array plus n, address of first element, address of an element beyond the last element, and we pass our own comparison function. The third parameter. After sorting, all the elements of this array will be sorted according to increasing order of x value. So when you print the output, you are going to get the output as, so you have three values. So the first smallest x value is 28. So you will get 28. Then the second smallest value 310. Then the last value 54. So your points are sorted in increasing order of x values. Now say you want to modify your order and you want to sort them according to y values. What changes you will make in this program? You will simply modify your my comparison function and you will put y here. And the output is going to change. The output is going to change and this time we are going to get values in increasing order of y values, right? We are going to get 54 first, then 28, then 310. Now say we want to further change our program. We want to print all the points in decreasing order of y value. So what changes you will make? You will change your comparison function to this form. Now it will sort all your points in decreasing order of y. So what will be your new output? Your output is going to be 310, the largest y value, then the second largest y value 28, and then the third largest y value 54. This is output of this modified program. Let us now talk about time complexities and internal working of sort function. Sort function internally uses quick sort, and if you talk about more details, it is a hybrid of quick sort, heap sort and insertion sort. By default it uses quick sort, and if quick sort is doing unfair partitioning and going to take more than n log n time, it switches to heap sort. And when your array size becomes really small, it switches to insertion sort. So worst case performance and average case performance of sort function is n log n. Also the number of comparisons it does, it's n log n. So it's an n log n algorithm which is an optimal time for any general purpose sorting function, and it internally uses intro sort.